In this video, we're going to get a good understanding of what moles are in chemistry. Not these furry little creatures, they're actually a unit of counting how many atoms we've got in a chemical reaction. So it gives us an idea of how many reactant particles there are or how many product particles are being produced. So let's take carbon and sulfur as an example. And if we look at their relative atomic mass, which is the mass number on the periodic table, for carbon it's 12, and for sulfur the relative atomic mass or mass number is 32. Now if we weigh out that many grams of each substance, so for carbon, if we weigh out 12 grams of carbon and 32 grams of sulfur, we'd actually have the same number of atoms. Both those samples contain the same number of atoms. So how can that be? Well, we've got to remember that they're different sized atoms. So here's a carbon atom with 6 electrons. Here's a sulfur atom with 16 electrons. And you've got to remember they've got different numbers of protons and neutrons in the nucleus as well. So sulfur atoms are much bigger and heavier. So if we want the same number in our sample, we'll have to weigh out a larger amount of them. So if we do weigh out the relative atomic mass in grams, so 12 grams of carbon, 32 grams of sulfur, how many atoms have we actually got? Well, they both contain 6.02 times 10 to the 23 atoms, or written a different way is this number. And we call this number Avogadro's number. And when we've weighed out that relative atomic mass in grams and got that number of atoms, that's what we mean by 1 mole. So it's a way of measuring how many atoms we've got. So to calculate how many moles of atoms we have, this is the formula you really need to memorize. Moles equals mass in grams divided by AR, and we're remembering that the AR is the relative atomic mass or the mass number on the periodic table, the top number. So if we put that into a triangle to help us rearrange it, mass is above AR, so mass goes at the top of the triangle, and underneath we have moles times AR. So that means if we were asked to work out the mass, cover up mass in the triangle, and that means mass in grams is moles times AR. Let's look at a few examples. How many moles of zinc would you have if you weighed out 200 grams of zinc? So each time we do need to write out the formula for it. So moles equals mass in grams over AR. So in this example, it's going to be 200 grams divided by 65, which is the mass number, the AR of zinc, and that comes out at 3.08 moles when I've rounded. Okay, you could write it as MOL as well, but not M because M stands for meters. Let's look at another example. This time it's asking for the mass. What would be the mass of 2.5 moles of iron atoms? So this time mass equals moles times AR. So that would be 2.5 moles times the AR of iron, which is 56, and the answer we get is 140 grams. Now try these questions for yourself, so pause the video and then when you finish, resume the video to mark your answers. In question 1, we need to write out moles equals mass in grams over AR, and the mass is 50 and the AR for magnesium is 24, and that comes to 2.08 moles. Question 2 is similar. So once again, we need to write out moles equals mass over AR. And in this one, that would be 10 grams divided by the AR for aluminium, which is 27. And that comes out at 0.37 moles. And the last question is asking for the mass this time, so we need to use the rearranged form of the equation. Mass equals moles times AR, which is 3.1 times 40, and the answer comes to 124 grams. Now, if we're dealing with molecules where you've got more than one atom, so it could be H2O or even O2 where you've got 2 oxygen atoms, we need to use this formula. Moles equals the mass over MR. And we need to remember that the MR is the formula mass or the relative molecular mass. If you've forgotten how to work out the formula mass, then go over one of the earlier videos where we spent a whole video revising formula mass. But you'll soon see in a moment. Once we put that into the triangle, we've got mass at the top and moles and MR at the bottom. So that means if we're asked to work out the mass in grams, it's moles times MR. Let's look at some examples again. So in the first one, how many moles of MgCl2 magnesium chloride would you have if you weighed out 150 grams of it? So first of all, we need to work out the MR of magnesium chloride. The MR of MgCl2 equals 24 for the magnesium plus 35.5 for the chlorine. We need to remember there's 2 chlorines, so that's another 35.5, and that comes to 95. We then use that in the equation we've just seen. Moles equals mass in grams over MR, which is 150 divided by 95, and that works out at 1.58 moles. Then in question 2, what would be the mass of 1.7 moles of sodium oxide, Na2O? So this time we need to use mass equals moles times MR. Let's work out the MR of sodium oxide. That's going to be 23 plus 23 for the 2 sodiums, the 2 NAs, and then 16 for oxygen, which comes to 62. So we can then put that into here. We've got 1.7 moles times the MR, and that comes out at 105.4 grams. Okay, so have a go at these practice questions. Pause the video. Once you've finished, resume the video and mark your answers. In question 1, first of all, we need to work out the MR of CuO, which is 63.5 for copper, plus 16 for oxygen, which is 79.5 in total. Then we can use it in the equation moles equals mass over MR. So that's going to be 400 grams divided by 79.5, which comes to 5.03 moles. Question 2. Once again, we first of all need to work out the MR of CaCO3, which is 40 for the calcium, plus 12 for the carbon, 16 for each oxygen, and there's 3 of them. That works out at 100. Then we can feed that into the equation. Moles equals mass over MR. The mass is 20 grams divided by the MR, which is 100, and the answer we get is 0.2 moles. In question 3, we're going to be using a different form of the equation, but we still need to work out the MR of potassium chloride first. So MR is potassium, which is 39, plus 1 chlorine is 35.5. So the total MR is 74.5. And then we do mass equals moles times MR, which is 1.3 times 74.5, which is 96.85 grams. So remember, to work out the moles, if we've just got atoms on their own, it's moles equals mass over AR, which is the relative atomic mass. If we've got molecules, more than one atom joined to something else, then it's going to be moles equals mass over MR, or the formula mass. But at the end of the day, it doesn't matter if you write AR or MR in the wrong place in the formula. You're still going to use the right numbers and put them in the formula correctly, and you'll get the right answer. The most important thing is you show you're working out so that you get the right answer, and you also pick up marks along the way if you do make a mistake somewhere.